This is gonna be a merge sort video. This and merge, quick, and hash is probably the three most important subjects to know for this midterm. And recursion, because without recursion you can't do merge. So you really need to know your recursion. Once you're done with your recursion, you would learn all the easy sortings just to get warmed up, and then head into the merge. So if you've skipped the past videos but you don't get them, I would suggest you go do them first and then come back instead of jumping right into merge. So how does merge work? Merge is the divide and conquer type way to solve problems, which is you split them into small parts and you solve the smaller sections of it. So we'll go straight into time complexity first. So the regular time complexity for a bubble sort, selection, or insertion is n squared, right? So it looks something like this, and this is O of n squared. Now when it comes to merge, it's O n log n, which is also something similar, but it's a little faster. I wouldn't say a little faster, it's a lot faster, but because I know log, the log n graph looks like this. So just because this has log n doesn't mean it looks like that. It looks very different, as you can see. So this is O n log n. Okay, this is one of the fastest, well, not like the fastest, but it's one of the fastest ways to sort, comparing to the n squared. And so that's the time complexity of a merge. For a merge, however, the space complexity is linear. So you'll be going straight. O of n. Alright, while for things like bubble, selection, or insertion, the space complexity is O of 1, constant, because it doesn't use any space. Alright, now what is a merge sort, or how do you implement a merge sort? So a merge sort really has two functionalities. Alright, the first functionality is you keep splitting an array in half until it is singular like this, just an array of one element, or 0. After you do that part, you will take every two consecutive 2's, or like one beside the other. You're like, okay, this, compare it to this. Which one is smaller? Is 27 smaller? Then 27 goes first, then 38 goes next. And the same thing here. Then once you do that, then you'll go here, you'll select the first two from both sections, and like, okay, which one's smaller? This one's smaller, so you put this one first. Then you move to the next one, and you don't move this yet, and you compare, oh, this one is smaller now. You'll put this. Then you'll move to the next one. Which one's smaller out of these two? This one. And then you place this one. There's one edge case you gotta handle, which is what if this had 2 and this had 3? Like let's say this is like 50. Then after you place this one, you have to create 2 while loops for the left one and the right one, just in case they're bigger and there's nothing they compare to. You're like, okay, if there's nothing they compare to, just start. So if it looks like this, just start listing them right beside it, one after the other, without comparing to anything. Okay, so it looks a little bit complicated, but once you code it, it's actually a lot easier to code than it is to explain, I guess. So the first thing you want to do is create a base case. Remember, if this is a recursive function, then you need a base case. Your base case is going to be once the array has length of 1 or 0. So you see, when this is my base case, so I want to recurse downwards until I reach this base case. Then I want to start going back up. So I know in this it looks like it's 2 sections, but this section never happens. These are not function calls. It's actually, it will go downwards. once it reaches here, it goes back upwards. It doesn't actually like go more downward like in this way. Actually, the recursive call will start retracting. You know how in factorial, if you're doing a recursive call, you'll do 5 times the factorial of 4, which is a function call. Then you do 4 times factorial of 3, which is a function call. Then once it gets to 1, it never goes downwards like this. It actually goes back upwards, and it will go, okay, it returns 1, 1 times 2, and it returns 2, 2 times 3, and so on. So it actually goes back upwards. Okay, it's just this is the best drawing I could find that kind of explains it. But here, let's use a different color. So once it reaches here, it goes backwards and it replaces. So whatever this array up here, it will switch it because, you know, 27 is less. So 27 will go here, 38 will go here. And then same thing here, this is 3, this is 43. Then it will go upwards again, and it will compare these two, and it will sort it. And then by the time it reaches the top, everything is sorted. All right? So the first thing you want to do is obviously split it into 2 parts. What is my base case? My base case is obviously when I reach this section, then I want to start going back up. So when my array dot length is less than 2. Now I know I said if it has 0 element or 1. So if it's less than 2, that means it has 1 element or 0 elements. Okay? When that happens, return. You're basically telling it, okay, go back up where you came from. So what's here? This method must return a result of type. Maybe that's why. Ooh. So this actually doesn't return an array, and I'll tell you guys why. So here, I'll copy this. I'll put it here, and then here I'll say, this is very important for you guys to know. So why does this not return an array? Because in Java, when you pass an array to a function, it is a pass by reference, not a pass by value. And if you remember your other coding classes like C++, passing by reference is you pass the actual location of the array, and you manipulate the array directly. While pass by value, you pass a copy of the array. And so when you manipulate that copy, the original array never changes. In Java, whenever you pass an array, it's always passed by reference. So when I'm passing it here, the actual array, this array, gets changed directly. And so I never need to return it. As long as when I'm done with it, like when I call it here and I'm done with it, this array will change directly. And so I don't need to like do, random array equals this. Like I don't need to update it like that because it's already being changed directly. All right. So if the array length is less than 2, we return because that's our base case. Else, what do you want to do? Remember, we're gonna start up here. They're gonna give us some array. What's the first step we do? Is we want to split it into 2. How do you split an array into 2? That shouldn't be too hard, right? You want to first, what is the length? What is the midpoint, right? You want to split it into 2, so I need the midpoint. So I'll do int midpoint equals, or actually I'll just do mid equals array.length divided by 2, right? So this will give me, let's see, so if we have here 0, 1, 2, well, this will actually give me 1, 2, array.length doesn't start from an indice of 0, 4, 5, 6, 7. If you take 7 and you divide it by 2, it'll give you 3.5, but that goes, like it doesn't, Java doesn't round up. It will always go to the base number. So 3.5 will give you 3. So that's the number you'll be getting. Your midpoint now is 3, right? So let's, let me circle it. There you go. All right. Now that I have my midpoint, I have to create 2 arrays. One, that is this one, and one, that is that one. And so how do I accomplish this? You just create 2 empty arrays. So int, it's going to be an integer array, and this is going to be the left side. equals new int of some size. I'm not going to say size just yet. There you go. So now I have a right side and I have a left side. What's their size? So the left side, we know, is going to be 0, 1, 2, 1, 3, 3 inclusive, let's say. So it's going to be of size 3, but we can just say mid because the mid is 3, right? Then what is my right side going to be? My right side is going to be the array.length. So my length is 7. 7 minus 3, right? Minus the mid. And so now I have two arrays. One array is going to be this one. I mean, I did name it the right side, so it's technically this one, but you get the idea. So, okay, so now I have the two arrays. Once I have that, what do I gotta do? I gotta copy the values in them, right? These are just empty arrays. Now I gotta copy the left portion. So I gotta copy this. Well, thing is here it's like split up, but here let's assume we're going off the picture. I'll have to copy this in here, and I'll have to copy this in there. So how do I do that? First, I gotta do a for loop, right? And the for loop will start from I equals 0 to I being less than what? It has to be less than the midpoint, right? Mid, and then I plus plus. So how does this work exactly? I will be from 0. We'll copy it in. Then it will be at 1. Then it will copy it in. Then it will be at 2. We'll copy in. And then when it becomes 3, 3 is more than mid. It's equal. Well, it's not more than. It's equals to mid. So this won't be copied in. All right. So that is an important part for you to pay attention to because we're going to need it in the second loop. So this, when I is 3, because it's less than, it doesn't get copied into it. So then what I'll do here, I mean, I believe I could just do equals. So this will include the mid, but the mid here is only 3. If I do equals, that will add 4, which is more than this size. Okay, so do pay attention to your numbers. They do matter. All right. So actually we'll keep it as minus. You could always do this plus 1 and make this minus 1 if I want it exactly like this. But I'll just leave it with the easier implementation so I don't confuse you too much. All right. So now what do I want to do? Within every loop, I want to take the left side. And it doesn't, actually, yeah, so I was going to say it doesn't matter which side you choose, but it does matter because the sides do matter. That's what she said. So left side at I equals the array. This is the original array, right? ARR is the original array. At, what is this going to be? At I. So first I'm going to do, so if you see, I will take 0 at position 0. So 0 will go to position 0. 1 will go to position 1. 2 will go to position 2. And that's where it will end for us in this loop. Okay? So these will all copy in. And then it will stop. Then I'll have another for loop. Int, let's say j. I mean, you could use I, because I only gets defined within the for loop. And after the for loop is gone, it goes away. So I can redefine it. Now, what does my I start at? Now, I want my I to start at the midpoint, right? Because we calculated it. Here, let me remove all this. So we did it from, so this whole section got added. This is check marked. My midpoint is right here because it's an indice, right? If the midpoint is 3, that's an indice. That's where my midpoint is. So I want it to equal my midpoint because remember, the 3 wasn't included. And then I'm going to do I less than array.length I plus plus. Whoops. So now it will go, obviously, it will go to midpoint, copy it in. So that would be, so array.length here, what is the array? 0, 1, 2, 3, 4, 5, 6, 7. So the array length is 7. So now we'll have the midpoint, which is 3, then 4, then 5, then 6. And then once it gets to 7, it won't run because that will be out of bounds exception. So it won't run there. So just make sure your indices are well defined. And now what we're going to say is right side equals, well, right side at I. But you see here, I mean, actually this works. So I'm going to show you actually two ways to do it. So this is right side, which will go from the midpoint to the array at I. And this will copy both of them. All right. Now one more way to do it is you could do 0 here. You can start I at 0 to I at array.length. And then what you can do here is you could say it's I at, oh, I see. Actually, I realized the issue. So you can't actually, you have to do it this way. But you have to remember to do minus mid here. Okay? Now, the reason you do minus mid here is because, you see, for this section, you want to go from the beginning of the array to the beginning of the array, which is right. However, for the right side, you are going from the midpoint, which is 3. You want to take 3 to place it at index 0. Okay, so that's why you got to pay attention to that. So here, what we're doing is 3 minus mid is 0. And then when mid becomes, well, when I becomes, let's say, 4, it will be 4 minus 3, which is technically the 1. So this is very important. Make sure you pay attention to this little trick right here. Okay? Because the right side array, you want to start at index 0. However, the original array, you want to start from the midpoint. Okay, so that's that. Now, well, unfortunately, in the midterm, you can't run your code and check. But here, we can. So we can do system dot, what is it, print? I can't remember what it was. I can't believe I can't remember that. Oh, sucks to be me. There it is. I'll take that. And you see what we'll do here is I'll print left side and I'll print my right side. Just to show you guys that the split was good. There you go. I'm gonna comment out these sections. Actually, let's comment out the whole goddamn thing. There you go. So now let's run it and see if we got it right. And as you can see, that's my left side. Well, let me actually, let me keep this one, so it shows me the original array, and then see if it split it properly. So the original array, 27, 19, 13, 47, and 4. So that got copied into the left side. And the right side is 11, 49, 29, 44, 24, and that got copied to the right side. So you see, the split is happening correctly, and that's good. Now what do I need to do after I've done the split? This is where you get to the recursive case. And then what we're going to do is call the merge sort again. So I'm calling the function itself, and then I'm going to pass it the left side, and then I'm going to call merge sort again and pass it the right side. Okay, so once it gets to this split, so right now, here, let me remove all this. Now what happens is, let's say at the first time we call the function, we have this function. We have this array, and then we get these two arrays. Then I take these two arrays and I pass them to the function as the left side and right side. So then we get these two arrays again. Following? So we'll get now 4 arrays. And then I pass it down again, and now I get 7 arrays, and each array having a number. Now once that's done, that's when we will reach our base case. Once we get to here, right? The merge sort will run, and it will pass either an array with 1 element or an array with 0 elements, right? So that's what it gets passed here, either 1 element or 0 elements. this will run, and this will return. Once this returns, right? Once this returns, now we get to the step to go backwards. What do I want to do once it returns? So remember, I called this, I gave it empty, it made a new call, but this call returned. So now, this function call returned back. Under here, what I'm going to say is merge. Right? And when I want to merge, remember, this is us at the last step. This is us right here, assume. Okay? So at the last step, we have one element and another one element. So in these two, there is one element here and there's one element, or maybe no element, but it's either one or none. Okay? So one element here, no element here. I'm going to pass that one element and no element into that merge function, which I'm going to make, to have it merge the two sides in a sorted manner. Okay? So right side. And I'm also going to pass it the original array. So that's the three things you want to pass it. And now we're going to create public static void merge. And it's going to take left side, right side, and the array. Now, what do I want to do here? This is the part where we're going backwards. And when we want to go backwards, we want to compare the left side array to the right side array and put them together such that they are in order. Okay? So that's what we're going to do. First, I'm going to have array length, or I'm going to have left side length equals, just because we're going to use it often, so it's better to do it like this, and int right side equals, well, right side length equals right side dot length. All right, and I'm not sure if I'll use the array length, but I'll take it just in case I do use it, and if not, I'll remove it after. All right, so your merge function is actually not a recursive function. That is just a helper function. And all you gotta do is you take two arrays, left side and right side, you sort them, and you place them in the original array in a sorted manner. Okay, so how do we do that? First, you can do a for loop because you don't know how many loops you're supposed to make. And that's why we use a while loop. Why do you not know how many loops you want to make? Is because comparisons. For example, if this was a length of 2, if this was actually 2, let's say this was 1 and this was 3, the comparison I'll make between 1 and 2, right, which will get 1 placed, and then I'll make a comparison between 2 and 3, and I'll get 2 placed, and then I'll do 3. But you don't have a kind of the order of who's going to go first, and that's why we use a while loop, because we don't know how many occurrences we're going to have to do. So, but the structure of the while loop is going to be the same as a for loop. So we're going to do int I equals 0, j equals 0, and k equals 0. I is going to be the beginning of the left side, j is going to be the beginning of the right side, and k is going to be the beginning of the original array. All right, and now we're going to do a while loop. What do I want to do? So what I want to do, we're going to actually take the case here. Okay, so if I want to take these two, well, actually here, let's go down because this is what we're supposed to do. So let's say here, I want to call my merge. I want to merge the two. What do I have to do? I want to start here and start here. While the left side is, let's say, smaller than the right side, then make the left side go to this location and move on to the next one. Okay? So this will keep going until, what happens? Until I gets to, so this will keep going while I is less than or equals to left side length, right? And then and j is less than or equals to right side length. Now what does this mean? What I'm doing here is I want this to run while I have some I, and I have, well, here, hold on, let me keep having to delete because I hate having too much clutter. Okay, so why is it selected? Okay, there you go. So this is my I and this is my J. I want it to compare. Then let's say I goes here and J goes here. I want it to compare. And then I goes here and J goes here. I still want it to compare. When J goes to this location and I'm done with my comparison and it's been placed, then I want to stop the while loop and I want to fill whatever is left. Because remember, once you get to this step, this whole array is sorted. This whole array is sorted independently. But together, when you want to combine them, they're not sorted. So once I'm done the combination, this is all gone, everything after this must be greater than whatever is in here. Alright? So that is the idea here. That's what we're trying to accomplish. So that's why I have it. So if I is less than, so if the length, let's say, is 4, I will run when it's 0, 1, 2, and 3. But if it equals 4, I'm reaching somewhere I don't want to. So I believe this is supposed to be less than. Can't remember. We'll test it out and see. So if I is less than the left side and J is less than the left side, then what I want to do, if, now I want to check which one is smaller than the other one. So let's see, left side, if left side at I is less than or equals to the right side at J. So what I'm saying here is if this I, so this is when I'm doing my comparison. I'm saying is this is 3 less than J. If it's less than, which it is, then place it at whatever K is. Because remember, that is the smallest one. So I'm going to do array at K equals left side at I. Right? So this is what me, if this is less than the 9, then place the 3. Once you place the 3, I want I to increment, to go to the next one. I want I to increment and go to the next one, so let's increment it. Alright, now I also want K to increment, because we place this at K, we place this at K0. But since now I place something at K0, I want K to go to the next section and place something in the second spot. So, K plus plus. Alright, so I hope you guys are following so far. Now, what happens, so else, what happens if left side is not smaller than right side? That means, well, right side is smaller than left side. So now, we'll do the same thing, except we will place the right side, because we just, if this doesn't run, that means right side is smaller. So we're going to want to place right side instead. And right side is J. And so then we'll have J plus plus again. And then we'll have K plus plus. Okay, so that's your while loop. This will keep running until either I is less than left side or J is less than the right side length. And now I remember it's not equals, because if it is equals, I will become the left side length. And then I'm going to try to access something that's out of bounds. So it is less than. All right. Now this is basically done. This is me merging them. It's just basic code really. I'm not doing anything fancy. All right. But what I do want to do is, what if, remember, what if I compare all of them and J is done, and this while loop will exit, but there's still one more element in my left side that I haven't included. How do I do that? I'm going to make two while loops. While something and while something else. In the first while loop, I want to check if I is less than left side length. Because that means I, so here, hold up, let's do this. I'll clean up. Okay. Ooh. So here, this size, or length, array.length, is 4. But my I, when j is complete, my I is still here. So, and this is 0, 1, 2. So my I is at indice 2. Is 2 less than 4? Yes. That means there's still things left to do. So what I'm going to do then, while I is less than, and actually this will increment. So it won't be here. By the time it's done, it would actually be here because of this increment here. So when left side, I'm just trying to process it through. When right side gets done, it gets placed down. J increments. The loop doesn't go anymore. Yeah, so actually no, I was right the first time. Every time I question myself, I'm like, why did I do that? Because it always turns out to be right the first time. Anyways, so I will be less than. Now what I want to do is have 38 be placed at K. So array at K equals the left side at I. Right? So right now what I'm doing, I'm placing 38 down. And then I'm also going to place, well, in my case, actually, 38 will get placed before J runs out because J has a bigger one. Then J will be placing the 82. Or, well, here, J won't be incrementing, then I will finish. So in this section, we are going to actually need, it's better to explain it using the second method. But we'll have to do this anyway, so I'll just go through it. And I'll show you guys K++. All right. So that's done. Now I'll use the second example to explain it because that's probably the more accurate one of what actually happens. So this one handles when the right side is like leaking, let's say. So how does that work? Here, I is gonna be here eventually, and J is gonna be here. Then they're gonna compare. And then 43 will go in next. So 43 will go in next. Once 43 goes in, right, for this section, once 43 goes in, I++, right? So then I becomes 5. So here 0, 1, 2, 3. So actually, so I equals 3. Then I++, I equals 4. And then I'm doing the check. Is I less than the left side length? Left side length is 4. So 4 is not less than 4. And so this while loop will stop. However, 82 hasn't been placed yet. So this while loop will first run. Is I less than the left side length? So it's still 4 less than 4. So this won't run because this is false. Then we'll go to the second loop. And back is J less than the right side length? And so J currently is 0, 1, 2. So J is equals to 2. The length is 3. Is 2 less than 3? Yes. So then what happens is I will do array at K equals the right side at J, which is indice 2. So now the 82 gets placed, and then we're going to do J++, and we're going to do K++. Now you'll be like, why are you doing K++, J++? There's nothing after. But you don't know that, right? You don't know if it's after. So let's assume that there is nothing after. And so we increment it. Like, will it run and attempt to do extra? So K++, K will become 8, because this is indice 8. Well, it starts from 0, so this is technically 7. And then J will increment, and J will become 3. And then I will check, is J less than right side? 3 is not less than 3, and so it won't run. And that is about it. I hope I haven't forget a couple things. I do talk a lot, and that kind of makes me forget something sometimes. But let's hope I didn't forget anything. All right, let's run it. What? Oh, there it is. So random array. Let's get our little merge sort. And there you go. It's sorted, guys. Wait, why is the random? Oh, I thought the random array was sorted. So this is the random array, and this is the sorted. And so let's say I want to flip this. such that instead of it's ascending, I want it to be descending. How do I do that? Let's see here. What if I flip this? I have a feeling that this is the one, but I might be wrong. Oh, and that's actually right. That is the one. So this is where you switch it from. Just like bubble selection sort, it's just a matter of one little thing. And that makes it go either ascending or descending. Okay? So that's merge sort. I hope it helped. Please do practice your merge sort. The best thing, to be honest, the best thing I would say to do is always have like a little drawing that you can go back to. And it's way easier if you can visualize it. Like coding up a visualization is so much easier. And there's a lot of ways you can code your merge, but this is the easiest way I found, or the easiest way to understand. So the way you want to do it is a couple steps. One is have your base case, which is for a merge sort when you have a array with a single item. Okay. The second thing is split those arrays into two sections. Once that's done, you want to create basically the merge sort. The merge sort's job, this will always be the same. So the only thing you'll ever play with is this section, but this section will always be the same. So if you understand that the merge sort is just splitting arrays into two separate arrays, you're already done with this part. This part is just, if you know how to split arrays into two separate arrays, like you don't need to memorize this. It's just, if you know how to code, you should be able to do it. Like it doesn't take any logic. All right? Just do pay attention to this little tricky part here. And then the merge, you want to do it, you just want to choose one case. Like you see how I chose one case and I just built it for that one case and it ended up happening for all the cases. That's really how you do it. So the merge is not even a recursion. It's just normal code that takes two arrays, compares each indice, and just selects them and puts them in the right place. All right. So I hope that helped. Don't forget, this is n log n, the speed. Actually, speaking of that, here, let's do some fun thing. I do have some code here that I would like to take. So we're gonna let's do an insertion. So that's what I'm gonna do here. We're gonna do a little insertion. We're gonna see how long it takes. Actually, no. You know what? Never mind. That takes too long to detect fucking setup. All right, guys. Have a good day. We're done. Time out.